Hello everyone, this is Arisa tutorial video, and in this video you're going to learn and enjoy different math related topics that will surely help you understand and appreciate the concept of mathematics and its application in real life.
There will be questions which will be presented at the end of this video to be answered by you that will test your understanding in this topic. Don't forget to comment, like, and subscribe to our channel.
So first, what is sequence? Sequence is an ordered list of numbers which elements or terms is referred to the numbers that can be seen in a sequence, like sequence of 1, 2, 3, 4, and 5.
While the series is the sum of the terms of the sequence. Let's try to add the example given above. 1 plus 2 plus 3 plus 4 is equal to 10. So 10 is the series of the sequence 1, 2, 3, and 4.
So we say that in any given sequence we have this format, wherein a sub 1 is the first term of the sequence, and a sub n minus 1 is in this portion, while a sub n plus 1 is the next term after a sub n.
Our first topic is about arithmetic sequence and series. In an arithmetic sequence, the difference between a term and the next is constant, which is called as common difference. In other words, you can add the common difference to the previous term to be able to determine the next. The formula for finding a certain term of an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times t, where a is the first term of the sequence, d is the common difference, and n is the number of the term to find. For example, the sequence 1, 4, 7, 10, 13, 16, 19, 22, and so on. The first term is 1 and their common difference is 3. In order to get 4, we either use the formula or add the common difference to the first term. These two ways will help us to be able to determine the next terms. We can try to find a specific term by using the formula, and we can also do the other way right after to be able to check if your answer is right. Now let's try to find the ninth term of the given sequence. If we try to substitute the first term, ninth term, and the common difference to the formula, which will look like this, we would get 25. To check if it's correct, we can try to add 3, which is the common difference, to the 8th term, and we would also get 25. Next, let's discuss arithmetic series. Arithmetic series identifies a summation of the given arithmetic sequence. This uses the formula S sub n is equal to n times the sum of a sub 1 plus a sub n over 2. Let's try it with the given example a while ago. The arithmetic series of the sequence 1, 4, 7, 10, 13, 16, 19, 22, and 25 is 117. You can check if your answer is correct by adding it all manually. What if you are given with a sequence that doesn't have a last term given? In this case, we use another formula which is n over 2 times 2 times a sub 1 plus n minus 1 times t. Let's try it with this sequence. 3, 7, 11, 15, and so on. So in order to find the sum of the 6 terms, we can substitute certain numbers to their value such as 6 to n, 3 to a sub 1, and to find the common difference, we can just subtract 7 to 3, which will be 4, so write 4 to d. And there you will be able to get 78. Here we end the discussion about arithmetic sequence and series.
We now proceed to our next topic, which is the geometric sequence and geometric series. We first start with geometric sequence. Geometric sequence is a sequence of numbers wherein the next term after the first term is found by multiplying the previous term by the common ratio. For example, we have 2, 4, 8, 16, 32, 64, 128, 256, and so on. To get 8, we're going to multiply its previous term 4 by 2. Same is also true with 256 as our example, wherein we multiply 128 by 2. Thus, we can say the common ratio is 2. In this case, we use the formula a sub n is equal to a sub 1, our first term, multiplied by the common ratio, raised to n, number of terms, minus 1. Another example would be 7, 28, 112, 448, and so on. We're going to find the 10th term. We're just going to substitute 7 as our first term, which is a sub 1. Our common ratio as 4, since when we multiply 7 times 4 is equal to 28, 28 times 4 is equal to 112, and so on. Our number of terms, n, is equal to 10. And with that, we're going to substitute. A sub n is equal to our first term, 7, times 4, common ratio, raised to 10 minus 1. That results to 1,835,008, which is true if we're going to compute manually. On the other hand, when we say geometric series, it is a sum of geometric sequence where it contains finite and infinite sequence. For finite sequence, we have this formula. S sub n is equal to a sub 1 times 1 minus r raised to n divided by 1 minus r. If n, or the number of terms is unknown, then you will use this formula. S sub n is equal to a sub 1 minus a sub n raised to r divided by 1 minus r. Then in infinite, we have S sub infinity is equal to a sub 1 divided by 1 minus r, where r is less than 1, or the absolute value of r is less than 1. Let's have an example. Find the sum of the first 7 terms of the geometric sequence when a sub 1 is equal to 8, r is equal to 2, and n, number of terms, is equal to 7, because we are finding the first 7 terms. All we need to do is just substitute the following values, and since we know n is equal to 7, we use the first formula. So we have s sub n is equal to our first term, which is 8. 8 times 1 minus r, that is 2, raised to n, that is 7, divided by 1 minus 2. That will give us 1016. For infinite, let's take an example of a sequence 3 plus 1 plus 1/3 plus 1 over 9 plus 1 over 27 and so on. As you can see, this sequence is infinite. And all we need to do is substitute every value with this formula. Since this is infinite and we don't know the number of terms, so let us have s sub infinity is equal to a sub 1, and that is 3 over 1 minus 1/3. 1/3 because if we're going to multiply 1/3 by 3, it will become 1. 1 times 1/3 is equal to 1/3 and so on. This will result to 4.5, which is the sum of the sequence, that is infinite. And that's the concept of geometric sequence and series.